if we're going to make a definition that we hope is consistent with the things that we've just observed. And we're going to call angular momentum L, the quantity for a point mass, the product of the mass, the square of the distance from the axis of rotation. Okay, now, for all you symbol worshipers, you got to get it right. What does that R mean? It doesn't mean any random radius. It means the distance to the axis of rotation. Okay, and omega is the angular speed, speed or velocity, because we're not allowing the axis to change. Let's go with angular velocity about that axis. So this is saying, wait a second, where have we seen this pattern before? Maybe it will be clearer if we go, how about that? Where have we seen that pattern before? Center of mass. Before, we only had one power of the distance, and that was called the first moment. Bonnie, hi there. What do you think we're going to call that? Nailed it. Yes, exactly right. So this is the second moment of the mass. The I part ends right before the omega, so this is I times omega. Is it true that every bit of the mass for an extended object that's rigidly rotating has the same omega, has the same angular velocity? Like every point in the bicycle wheel, if I set it to spinning, rotates with the same angular velocity. Is that true? Yeah. How about the same velocity? No. I mean, is there any way even to define the velocity of the wheel? Different points are moving in different directions at different speeds. We're going to end up maybe saying, well, the only velocity we could define for this thing is if the whole thing is translating. And we'll get to that. But that isn't going to describe the going round. There is, however, the angular velocity, which is the same for all the points in the object. And so that we can use. Okay, so what are the dimensions of moment of inertia? So that's just mass and length squared. So m and L squared. And what about angular momentum? So let's just compare. Momentum is mass length per time, because it's mv. Angular momentum has 1 power of mass, 2 powers of length, and 1 inverse time from the omega. So what do you tell somebody who says, well, the momentum got converted into angular momentum? Can you add up momenta and angular momenta? They don't have the same dimensions. They're different quantities entirely. So we're going to investigate the rules for angular momentum. And from the demonstration on the stool without doing nothing, just when Marisol was spinning around before I handed her the bicycle wheel, if you have an isolated system, its angular momentum is conserved. That is approximately an isolated system, but there is a little bit of friction at the axle, so it is gradually slowing down.